In this video, we will learn how to find the slope of the tangent line to the curve at a given point. In the last video, we learned that the slope of a curve at the point of tangency is defined by the slope of the tangent line to the curve. Recall that by definition, the slope of the curve y equals f of x at the point P hk is f prime of h. This means that if we are asked to find the slope of the tangent line to the curve at the given point, all we have to do is to find the derivative of the function and then evaluate the derivative at a given point, say at point P hk or at x equals h. Hence, the slope of the curve or the slope of the tangent line denoted by m is simply f prime of h. For our first example, we are asked to find the slope of the tangent line to the curve y equals x cubed minus 27x squared minus 3x plus 24 at point 1, negative 5. To solve this, we have to let y be equal to f of x. So f of x equals x cubed minus 27x squared minus 3x plus 24. Getting the derivative of the given function, we will obtain f prime of x equals 3x squared minus 54x minus 3. When x equals 1, substituting 1 to every x in our derivative, we will obtain f prime of 1 equals 3 times 1 squared minus 54 times 1 minus 3. Performing the operation, we have 3 minus 54 minus 3, which is equal to negative 54. Thus, the slope of the tangent line to the curve at the given point is negative 54. For reference, here is the actual graph of the function as well as the line tangent to it at the given point. As for our second example, we are asked to find the slope of the tangent line to the curve y equals 2 cosine quantity x plus pi at point pi over 3, negative 1. To solve this, first, we have to let y be equal to f of x. So we have f of x equals 2 cosine quantity x plus pi. Getting the derivative of the given function, we have f prime of x equals negative 2 sine quantity x plus pi. When x equals pi over 3, substituting pi over 3 to every x of our derivative, we have f prime of pi over 3 equals negative 2 sine quantity pi over 3 plus pi. Getting the sum of pi over 3 plus pi, we will obtain negative 2 sine 4 pi over 3. Getting the value of sine 4 pi over 3, we have negative 2 times negative square root of 3 over 2. Getting the product of these two quantities, we will obtain square root of 3. Therefore, the slope of the tangent line that we are looking for is square root of 3. For reference, here is the actual graph of the function as well as the line tangent to it at the given point. At this point, you may pause the video for a while and try answering the given problem on your own. Once you are done, you may continue playing the video and check your work. In this example, we are asked to find the slope of the tangent line to the curve y equals e raised to negative x times ln x at point 1, 0. To solve this, first, we have to let y be equal to f of x. So f of x equals e raised to negative x times ln x. In getting the derivative of the function, we are to apply the product rule. So f prime of x equals e raised to negative x times the derivative of ln x, which is 1 over x, plus ln x times the derivative of e raised to negative x, which is negative e raised to negative x. In simplifying the given expression, we may factor out the common monomial factor, which is e raised to negative x. Thus, we have f prime of x equals e raised to negative x times the quantity 1 over x minus ln x. Thus, when x equals 1, substituting 1 to every x in our derivative, we have f prime of 1 equals e raised to negative 1 times the quantity 1 over 1 minus ln 1. Performing the operation inside the parenthesis, we have f prime of 1 equals e raised to negative 1 times 1 minus 0. Note that ln 1 is equal to 0. Simplifying the given expression, we have e raised to negative 1. Eliminating the negative exponent, we can rewrite e raised to negative 1 as 1 over e. Therefore, the slope that we are looking for is 1 over e. Again, for reference, this is the graph of the given function as well as the line tangent to it at the given point. Now, it is time to check what you have learned. Try solving the following problems on your own. You may pause the video for a couple of minutes to give you ample time in solving the given problems. Here are the answers to the given problems. You may now check your work. Did you get a perfect score? Good job! Give yourself a tap on your shoulder for a job well done. Did you miss a number or two? That's just fine. Try reviewing your solution or try solving the problems again until you get the correct answers. You'll get it next time. Remember, correct practice makes perfect. So, that's it for this video. See you on our next video.